Once again, we're using substitution to evaluate variable expressions for given values of the variables. Only in this lesson, our given values will all be negative, because negative numbers bring some special circumstances to this topic. Well, here's an expression we've seen before, but we have different values to substitute for a and b. So we'll do that first. And then we need to do the two multiplications. We do those. And now, because there's so many negative numbers in the problem, I'm going to choose to apply the definition of subtraction. So I rewrite the subtract 4 as add negative 4. I'm adding the opposite. Now I have three negative numbers to add, and the sum of those three negative numbers is negative 91. In our next variable expression, we have a grouping symbol, and we can apply the distributive property or not. So we'll do it two ways. We won't apply the distributive property the first way. On the left, we'll substitute the negative 9 in for a, and then we'll apply the definition of subtraction so that we can do negative 9 plus negative 4 and get negative 13. And then while we did that, we substituted the negative 12 in for b. We have two multiplications to do, so we did those, and then we added those two negative numbers, and we get negative 99. On the right side, we'll apply the distributive property. So we first substitute the negative 9 in for a, and then we put our handy little red marks so that we'll know where we're headed with the distributive property. That gives us two times problems we need to do, both 3 times negative 9 and 3 times 4. We do those two times problems, and at the same time, we substitute the negative 12 in for b on the far right. Now we apply the definition of subtraction so that instead of subtract 12, it's add the opposite of 12, and then we add the three negative numbers, and we still get negative 99. We're happy about that because although we did the expression two different ways, there's only one answer, and that answer is negative 99. Now let's take a look at substituting negative values in for variables that have exponents. And before we do, let's just take a look at a to the fourth power. And let's evaluate that for a equals negative 2. We know that a to the fourth power means a times a times a times a. So we substitute the negative 2 in for those four a's. We multiply. We do 2 at a time. The two negative 2's make a 4. The 4 times the next negative 2 makes negative 8. And the negative 8 times negative 2 makes positive 16. So we know that negative 2 raised to the fourth power is 16. But when some people substitute, they just remove the a and put in a negative 2. That causes a problem. Because if you just write a negative number, in this case negative 2, and then put an exponent, what that means is the opposite of 2 to the fourth power in this case. So if you write negative 2 and then have an exponent of 4, you're not raising negative 2 to the fourth power. You're doing the opposite of 2 to the fourth power. That's all about order of operations. So if we want to write it correctly, when the a is negative 2, in this case, when we raise a to the fourth power, the a is the base. So if the base is a negative number, we need to put parentheses around that negative number. And then we know that we're raising negative 2 to the fourth power, and we'll get positive 16. Well, let's get back to the expression. We already know that a to the fourth is positive 16, but let's substitute for all of those variables. And now, before we even worry about the exponents, we have a grouping symbol, 4 times negative 2 to make negative 8. And now we have three exponents to worry about. We know the first one is 16. We know that negative 5 to the second power, also called negative 5 squared, is 25. And the negative 8 times itself 3 times. That's 3 negatives in a times problem. And that makes a negative product, negative 512. Of course, we have to do 3 times 25 in the next step. And then we add, and the first two make 91. And the 91 plus negative 512 is negative 421. Let's now look at negative 3 used as the base and raised to the first 6 counting number powers. You'll notice if the power is an odd number, the product is a negative. And if the power is an even number, the product is a positive. And that's worth keeping in mind when working with negative numbers. let's take a look at how a calculator handles it. Well, the good news is, handles things correctly. So if you type the negative symbol followed by a 3 raised to the 4th power, what you're typing is the opposite of 3 to the 4th power, and the calculator will tell you that that's negative 81. If you put parentheses around your negative number and raise that to the 4th power, you'll get positive 81. The calculator also has a way of storing numbers to variables. Here I'm going to make x stand for negative 3. So, the key sequence is shown at the top, the negative key followed by a 3, followed by a special key. On my calculator it's labeled STO with an arrow, and that stores the value negative 3 to the variable x. The 4th key in that key sequence is a special key that gives you the variable x because x is used quite often. You'll notice there's 3 other icons on that key, and it depends on what mode your calculator is in, but in the default mode, you'll get the variable x. Then hit the enter key, and now, until you tell it differently, whenever you type an x, the x will be interpreted as a negative 3. So as you see, if you type x to the 4th power, after you've made x equal to negative 3, you'll get 81. Also notice that the variable is much like a grouping symbol. You don't need parentheses if the variable stands for a negative number. A calculator can also be used to do the problem we just did. I'll leave it to you to figure out how to use the alpha key on whatever model calculator you have, but on my calculator, this is what it looks like. We've stored negative 2 to the letter A and negative 5 to the letter B, and then we can type a to the 4th power plus 3b squared plus the quantity 4a raised to the 3rd power, and we still get negative 421, the same answer we got when we did it without a calculator. To summarize this lesson, once again, evaluate variable expressions by substituting given values for the variables, but be careful when substituting negative numbers for variables with exponents.